So I am on page M189. This is a continuation of the last set of notes you took. We're going to be writing the equations. So we're going to writing the equations for linear patterns. Okay. So if you look at this one, remember it had 6, 5, 4, 3, 2, 1 in all directions, or in the 4 directions. Okay, so if we want to write our equation, remember I'm going to write it over here, y equals mx plus b, where the m is the slope and the b is the y-intercept, or starting. Now, starting means equals 0. That's important. So we have used the process column, which you could use the process column if you wanted, but I'm going to try to get you guys away from that. So we know the slope is the rate of change. This side is changing by 1. This side is changing by 4. So we're going -4. So we're going to set it up as -4 over 1, which equals -4. So that's our m. Now our b is the y-intercept. If I were to graph these, I wouldn't want term 1, I would want term 0. So remember, you have to go back 1. So this is the first term. You have to go back to term 0. So I need to go back 4 more. So then I would do 25. I'm going backwards, so instead of subtract 4, I would add 4. So 25, 26, 27, 28, 29. So it'd be 29. So 29 would be my b. So then my equation would be y equals -4x plus 29. So that would be the equation. Now, I do want to check that to make sure that we do it correctly. So I'm going to use 6 in that to make sure. And I know I'm running out of room, but it's because I write so big. So I'm going to do a check, and I'm going to say y equals -4. I'm going to put in parentheses 6, and then I'm going to put plus 29. So I'm going to do -4. These calculators do have parentheses. If you're doing it on a phone, you would want to do -4 times 6 because you have to multiply first. So -4 times 6 would be -24, and then add 29. So -24 plus 29. On this calculator, to hit the negative, you hit this button right down here. If you're on the phone, you would have to hit the plus and minus slash thing. So it would be 5. So y would equal 5. So let's check to see. That one is 5, so our check is correct. The only reason I do that is because I want to make sure I didn't make a mistake. I know it's hard sometimes if you're working on an assignment at home that you can't just easily check with me. So you can always plug in your numbers and check to see if your equation was correct. Alright, so now let's look at number 2. This one is nonlinear, so we haven't talked about writing equations for those yet. Number 4. Okay, so we're going to do the same type of thing, but in this case, our slope would equal -6, or our m would equal -6. This would be our start, because remember, you're always looking for the 0. So this is our start, so we're going to use 150. So my equation would be y equals -6x plus 150. The slope goes with the x, the starting value goes with the adding at the end. So let's do our check. So check, we're going to do 3. So I'm going to write my equation, -6, 3 plus 150. That's a 50, not a 6. So then again, you're going to do -6 times 3. Actually, I'm going to do it all in one step this time. So you can, if you have a calculator like this. So -6. So remember, hit the negative down here. It will give you an error if you don't. So it'll be -6, 3 plus 150. And to put the parentheses like I did, I just hit the buttons right above the 8 and the 9. And it gives me 132. And 132 is correct. Okay, the next one we have is number 7. So we're going to do y equals the slope is 50, because remember these are all by 1, so 50 divided by 1 equals 50, so that would be our m. Oops, there's a glare. Okay, our starting value is 500, so I'm going to do y equals 50x plus 500. That would be my equation. I'm going to do my check. Sorry, you just probably heard my dog shake in the background, but that's okay. Now it's coughing. So I'm going to do for 3. So I'm going to plug it into my equation. So for my check, I'm going to do y equals 50 times 3 plus 500. So 50 times 3, you can also do it this way, plus 500 is 650, which that is correct. So it should have been hopefully a review for writing equations of linear, because that's what we've been doing. So hopefully that made sense. If not, let me know.